Hi everyone, my name is Aditya and in today's video we will be designing TinyURL. TinyURL is an application which allows users to input a large URL and get a smaller URL back. The main use of this is so that users can share web pages or addresses that are large in a smaller format. So for example, in social media like Facebook or Twitter. So let's get started. So let's first talk about the use cases of our service. So we have our user here, we have our service here. One use case of the system would be that users are able to input a large URL and get a smaller URL out. So we can call that large to small. On the other side of the coin, when a small URL is given to our system, we should be able to get back the original URL and redirect the user to the original page. So here we have the exact opposite, which would be to go from small to large. Let's think about some other use cases as well. We can allow users to customize their own TinyURL. So we can say that would be another use case. So we can say this is custom, and this is actually, we can say this is a subset of going from large to small. Another use case we can have is giving users the ability to expire, to give an expiration. So for example, if a user specifies that I want a TinyURL for my web page, but I want it to expire within 1,000,000 milliseconds, users should be able to do that as well. So so that's again within this system, or this use case, so we can say this is also expiration. Okay. So let's talk about the large to small use case first. So we're shrinking a large URL into a small URL. One way to approach this would be to generate a length of a string that encodes, that is unique to that large URL. So as an example, we can have, let's say we have like an 8-character string. So we have 1, 2, 3, 4, 5, 6, 7, 8. And within each of these characters, we can allow characters like A to Z lowercase. We can say A to Z uppercase. Let's allow digits as well. So doing this, we can see that for the first character we would have A through Z lowercase is 26, uppercase is the same, so 26, and then 0 to 9 is 10. So we would have 26 plus 26, which is 52, plus 10, which is 62. So we have 62 choices here. And we have the same choice for all our other 7 spots. So we can say that using this methodology, we will have 62 to the 8 unique smaller strings that we can generate to be used by our system. So then the question comes up: is this enough for our system? That answer depends on how many requests are coming in to generate small URLs. So depending on that answer, we can either maybe shrink the number of characters we're using to generate our TinyURLs, or perhaps increase it as well to allow for more possible permutations. So that's how we can tackle that issue. So now the question comes, how do we actually generate them, right? So we have 62 to the 8th unique strings that we can generate, but how are they actually generated and given to users when they want to use our system? And there's a few approaches we can think about. So let's think about random. So this would mean that once a request comes in, a random string is generated from these choices and given to the user as their tiny URL for whatever long URL they gave as their input. So we can do randomly. We could do it sequentially. So sequentially meaning that the first URL first request that comes in gets the first possible string from this construction. Then the second request would get the second, third would get the third. So here's two approaches. We can also consider perhaps a hashing based approach. So hashing. So by hashing I mean we take the tiny URL, we take the larger URL, we apply a hash function on it, such as MD5, and then we get a bit of strings and a string of bits, and then we use that to denote the URL we're going to give back to the user. So we have random, we have sequential, we have hashing. Let's talk about what are potential issues with the random approach. So with the random approach, what could happen is that there's two things that immediately come to mind. One of them is that if you have concurrent users wanting to get a URL, a smaller URL, what could happen is that because the requests are being processed concurrently, each of them could get the same small URL back, and that would be a problem for our system because we would have our mapping wouldn't be one-to-one. What I'm talking about is that if we have user A, right, and user A has, let's say this is their long URL, it maps to, let's say, short one, S1 will be a short URL, and then we have user B, and again we go from long to S1 in our random example where we give back the same small URL. So then what happens is that when our system, then when someone asks for S1, only one of these would be true. Only the redirect would only happen to either this one or this one, based on whichever long to small was stored last. So like whichever was the last put would win, and the data would be overwritten. So that's one. Excuse me. That's one potential issue with this approach, the random approach. The other issue would be, or a concern would be that you're asking for a random URL over and over and over and over again, and when there are a lot of like strings available, it's likely that you would get something random and that hasn't been used already, right? But what could happen is that it might take more than one request or even a few requests to get a unique random small URL that hasn't been used. So that's one potential downside of this approach, where we talked about the data being overwritten if there's concurrent users, or having multiple queries to be able to get a unique tiny URL. Let's talk about sequentially. So in sequentially, the approach was that we start from like 1, for example, and we just count up, and that's how we're giving URLs out. So that sounds like a good approach. But one potential issue with that would be like security reason. That if if you know if a malicious user or a group is able to figure out how we're distributing our URLs, they could exploit that information in some way. So that's one potential downside for the sequential approach. For the hashing approach, the idea is that you go from your long URL to a smaller to some a hashed version of that URL. So that would be a 128-bit string, for example. So then what we could say is that, okay, we have a 128-bit string, and then let's only take X amount of bits that we need to be able to represent all these 62 to the 8 numbers. So that's one approach. We could argue that there could be collisions again in that because you're only using like a prefix of the 128-bit string, and as you use less and less bits, the probability of having a collision between two different unique URLs that are getting mapped to the same hash value is, that probability increases. So one way we can get around that is to use a longer bit string, but then that comes with a downside of having more space, right? So then our URLs would be longer, or our short character string here, which is this is 8 characters, could be 9 or 10 or longer. So that's we would have to consider the pros and cons of that. One other approach we can do is perhaps split out the ranges of the of these numbers. What I mean by that is that we can have, for example, let's say one server be responsible for giving out any number from 0 to, let's say, 1 million. So 1 billion. So this goes from 0 to 1 million. This would be server 1. We could go from, let's say, 1,000,001 to 2 million to server 2. So what I'm saying here is that we could split up our 62 to the 8th numbers into different ranges, give each server its own range, and what we can do then is that whenever we get a new request, we can distribute it onto one of these servers, and that server will give out one of its numbers that hasn't been used and to that user. So that's how that would work. And the benefit of this approach is that so one immediate benefit would be that the load is getting distributed across X number of servers, so that helps with being able to generate small URLs quickly. The other benefit is that, for example, if one of these servers goes down, we only lose, let's say, 1 million numbers, but if you have 62 to the 8th total numbers that you can give out as your smaller URL, it's okay. So that's one other benefit of this approach. Let me also talk about how this actually works. So I wasn't very clear in how we would go from a number to an actual string like AZ or A to Z, A to Z, or 0 to 9. So when we have a number like, let's say we have, so let me give an example in base 10, and the same logic applies here. So in base 10, when we have a number for like, let's say we have 125, right? We have the number 125. How this is represented is right. You have essentially. Let me think about this. We can each digit, right? 125, to make this number. What you do is that you take if you're given this as a string, right, and you want to create the number 125, what we do is we take the modulo 10, right, because we're in base 10, so we would say, let's get this digit, so this would be 5. Then we divide this number by 10, and if it's integer division, so we would do 125 divided by 10, which would give us 12, and then we would do the same thing, so 251. Then we can rotate to get the actual number. So this applies to this as well, because what we can do is, instead of dividing or doing modulo 10 and then doing divide by 10, we can do modulo 62. So that will give us, digits from something from 0 to 61, and each of these 0 to 61 could represents all these different characters. So for example, this lowercase a could be 0, this 1 could be b, so on and so forth. So from this big number, if we do this process, we can generate the actual string, and based on how we define the mapping from 0 to 61 to the characters we have here. So that's actually how we would generate this string. So we have that. So we've talked about 3 different approaches. How we can generate our small URL. So we've talked about this. We haven't talked about the custom approach. So in the custom approach, we want users to be able to specify their own string. So it depends on if we take this approach of breaking out different or giving ranges to different servers. This approach wouldn't work. The approach we have here wouldn't work because the range is already predefined here. So what we could do is that we could convert this, whatever the small URL is, or the small customer string is, and see which range it falls into, then ask that server if that number is available, and then give it back to the user. So that is one approach. So we could do that. The limitation on that is we restrict the number of characters for users who want to make their own custom tiny URL to be 8 characters. So that is one constraint on that. We haven't talked about expiration, so we can talk about that as well. Expiration, again, is the feature where the mapping we've defined going from long to small is actually, it gets invalidated, so we throw it out. We could approach that with maybe a process where every predefined interval, or after X amount of time, we scan through our mappings and see which mappings have expired, so we can have like a date timestamp. So what I'm talking about there is that in addition to storing like small to like the long, we can also store so S1 would go to long plus let's say date time plus the milliseconds that the users define. So we would take the current timestamp, add on that X number of milliseconds, or however we want to define expiration, and we could remove actually no, if we want, so let me think about this actually. So we would store it like this, and then what we could do is say we could have a map, for example, that goes between let's say it's within, like, if we do it by day, there would be only 365 days, so we could do it by day actually. So what I'm saying is that we could say, let's store a date time object, right? And then what we could say is from this date time, we could store the actual small URL, so like s1 ... So what this is saying is that if we have a short URL pointing to our longer URL. In addition, we have a date time mapping to the small URL, meaning that on this day, on this day, these URLs are going to expire. So what we could do is that at the end of every day, or at the start of every day, we can essentially say, okay, let me look at the URLs that are expiring today and then just remove them from this list and then remove them from our data store. So that's how we can think about the expiry as well. Yeah, and the other thing we have to talk about is going from small to large, which is the reverse of what we've discussed. That is, I mean, that's a simple lookup. So if we store our if this is our model of how we're storing our data and URLs, we can do a lookup and say, okay, S1, whenever a user says, here's S1, what's the long URL associated with it? We just give them back the longer URL, or we redirect them to that page. So that's how we can do that. Another thing to note here is that this operation, this use case here, is going to happen we're going to expect more redirects or going from small to large than going this way from large to small, because if we think about it, we can have, if something is trending and someone shares like a live video or like a video URL using like video URL transcribed as a tiny URL, let's say on Twitter or Facebook, and this is going viral, there's going to be a lot of read requests, meaning a lot of people trying to access that tiny URL and get back, go to the bigger URL. So it's going to be more read heavy. It's expected to be more read heavy, so we can actually store this mapping into, let's say, like in a cache where it's easily accessed. It's faster to access that, and that would actually decrease the amount of load being given to our data store. And we can actually do that, and once it's in the cache, we can put it in the we can just leave it there until it expires, or we can think about different caching mechanisms. But the point I was trying to make is that it's static, so that meaning that once we have like S1 points to this big URL, that's always going to be the case. Like this isn't going to be changing based on if this is fixed, this will be fixed as well. So yeah, that is how we can think about designing TinyURL.